In today's lecture, we are going to understand the concept of matched filter and correlator detector. Both the devices are optimum receivers which are used for the detection of signals in the presence of noise and also used to increase or maximize the signal to noise ratio, but both are differ in their implementation. So one by one we will take both the techniques. First we will see how matched filter works. So this is a block diagram for the matched filter. You can see a signal GT which is to be transmitted. It is added with the noise, or you can say during the transmission the noise signal is added with this signal. The output of this is xt, which is basically the combination of signal plus noise. This signal is given to a linear time invariant filter with a response ht. This response gives the response as yt. So as the mathematical expression we can see that xt is equals to gt plus noise and yt is equal to g naught t plus nt. That means this yt is basically g naught t plus nt, where this g naught t and nt is what? G naught t is the linear output corresponding to gt. So the signal gt, which is to be fed to this linear time invariant filter, it gives some output g naught t. So we are considering the output g naught t, which is linear with respect to this input gt. And then this nt, this is the filtered noise. Obviously the noise is filtered using this linear time invariant filter. So filtered noise plus the output of this GT signal, by adding we will get the signal YT. Both are generated by signal to noise component of XT. So XT is basically having both the component, signal component and noise component. So both are generated by this XT. Purpose of this is what? Purpose of this is to maximize signal to noise ratio. How? I will give you an example so that you will understand the concept better. Frequency response of this is HF is equals to GA SF abstract e raised to the power minus 2 pi ft1, where GA is the maximum gain of the filter which we are using. Then SF is the Fourier transform of the input signal. Then S abstract F obviously is the complex conjugate of SF. And then T1 is the time where observed signal is giving the maximum value. As you can see, a decision device is connected. At t is equal to t, this switch will be closed and this decision device will make its decision. How it will make the decision and what is the decision? Basically, what is the data? Data is in the form of zeros and ones. And how you will transmit zeros and ones? You will transmit zeros and ones in the form of different voltage levels. So, for example, if your transmitted data is 0, 1, 0, 0, 1. So, how you will transmit the data? 0 volt, 1 volt, 0 volt, 0 volt and 1 volt. This is how your signal is transmitted. When it is passed through the channel, the signal will be something like this. This should be the ideal signal. That means this is bit 1, this is bit 1 and these are bit 0. But what happens when it passes through the channel? Some noise which is already present in the channel will add up to this and then make the signal something like this. So when such type of signal you will receive, these three basically gives you an impression whether it is 0 or 1. You cannot decide. At this instance you can decide that this bit is 0, this bit is 1. In these three sequences, noise is added. So match filter, what it does, it increases the signal component and reduces the noise component simultaneously. So if this particular signal is 0, that means some noise is added to this, so the noise signal will be suppressed. And if any signal like this is bit 1, this is a signal component, so signal component will be enhanced. So when it is passed through the match filter, the output of this will be this. So here you can easily make up that this is bit 0 and this is bit 1, and This way you can easily distinguish between bit 0 and bit 1. This is how match filter works. So the next topic is correlator detector. In correlator detector, we use the carrier signal at the receiving end. As you can see, the received signal is added with the carrier signal, and then this signal will pass through the low pass filter. So how it functions, basically you have seen in the various analog modulation techniques as well as in various digital modulation techniques like amplitude modulation, ASK, FSK, PSK, in all the techniques, whatever the signal or whatever the modulated signal you have transmitted from the transmitter, it will be demodulated with the help of the same carrier signal. So it is very essential that you have to generate the same carrier signal which you have used at the transmitting end. So when this carrier signal is multiplied with this received signal, then it will be passed through a low pass filter which will remove the high frequency component and gives you the desired input which you have used, or desired signal which you have used for the purpose of modulation. So this is how correlator detector work. As you have already understood the concept of correlator detector in many videos, because we have already studied amplitude modulation, amplitude shift keying, frequency shift keying, pulse amplitude modulation, and so on. There are all the techniques in which we use the carrier signal at the receiving end. So this is how correlator detector works. So basically this is also an optimum filter which basically used for the detection of signal as well as to maximize the signal to noise ratio. Thank you for watching.